going to show you how is the setup looks like. First, we install the software in the computer, and then secondly, we connect. This is the receiver. It's very light. I just connect to my laptop just using normal USB, and then this is the charger dongle for the sensor. So this is the sensor. What I need to do is just have to dock inside the system. Right, very easy. That's all. And I can actually do the configuration. So I go to the setup, and then let's say if I want to, I will rescan the hardware, what is available on the sensor. Okay. So here, now it detected two sensors. Let's say if I want to change the sensor, I also can change by dragging here directly. All right, you can see. Then I just have to apply the configuration. So I can do it based on the test that I wanted to do. It can be on the sternum, it can be on the lumbar, it can be on the foot. And I just have to set it up in the sensor before that, right? And the good things about this is actually the sensor can go up to a lot more sensor for the full body. All right, so it's set up that it's been there. It will also shows the name, so you can see the name actually is, let's say this sensor is left foot. Left foot, you can check this is the left foot, right? It already configured inside. So let's say now I want to do the sit to stand test. I will do I need to put it at the lumbar and also sternum. All right, and then I just have to apply the configuration. And I no need to do any configuration, calibration, a room that I need to do that. But it's very easy. Just in less than 3 minutes, I can actually do the setup easily. All right. So this is how it looks like. And what I need to do next is I go to select the subject, and then I can run the test. That's all. Right. Thank you. Today, I'm going to demo you on how to use Mobility Lab to analyze our gait performance. All right. So now we are at the front page at the subject. We're going to select one subject. We can create one as well. We're going to do a new test. So here we can do quite a number of tests: freeform, walk test, TUG, swift, 360-degree turn, sit to stand, SAW, and others tests. This is all the standard clinical tests. Well, what makes the difference is we have this objectively, we can collect the data. All right, I'm going to do an open-ended walk test. So now what I need to do is to put the sensors. So here we call it a motion sensor. Wearing at my body here is a motion sensor. I have to wear at least 3 sensors for a gait analysis. So this is the sensor one. Another 2 sensors is at my foot, left and right. All right, and very easy. I just have to, like this, I just have to wear it here at the middle of my foot, both. So now I'm going to run a simple test on how is my gait performance. All right, I'm going to select next. Okay, so what I need to do now is I will have to select my data. At the same time, the sensor will record my data. I have to put here. All right. So now let's look at how is my data looks like. So here is the data all we can look at, and I'm going to show you one by one. This is cadence. So you can see I'm a little bit lower than the normative data. The gray color actually is the normative data. Left and right is almost the same, step per minute. This is my gait cycle duration, 1.3 seconds, more than the normative. So this is my gait speed, a bit slower. Double support, I can see my terminal double support, exactly how it is, compelling left and right. And I can see as well my elevation at the mid swing. My right is a little bit higher compared to the left one. Lateral step variability, my right side also a little bit off outside. You can see, using our human eye is very hard to see, but with sensor we can exactly capture. You see the right side is 7 cm and left side is 4 cm. Circumduction, all right. My foot strike angle, left and right. The toes off angle, stand, step duration, strike length, swing, toe out. The left side is a little bit, you can see here, the left side is a little bit more than the normative. All right, the turn angle, turn duration, I use 2.6 seconds to do a turn. You can capture as well. And this is the turn velocity, 176 degrees per second. It's still within the normative data, right? Step in turn, I use about 4 steps to do a turn, which is normal as well. APA duration, the first step duration, the first step range of movement, maximum acceleration front and back, and all other data. So this is how we can analyze our gait easily in less than 5 minutes. So we call it a portable gait lab because it is very portable and there's no wire. We don't need to do a calibration, and we can do a gait analysis easily anywhere and wirelessly. So now I'm going to demo another scenario. Let's say if I'm a patient, how is my result will looks like? We're going to do a comparison. Okay, so we're going to do a new test, the same test, open end. Right, I'm going to stimulate my left side is a stroke patient. Right, imagine my left side is there's a weakness. So how normally the stroke patient they will look? Probably they will be like this. And here we're going to see some differences with what I'm doing normally just now. All right. Okay. So I'm going to do it takes, so you can see that the cadence. This is the gait cycle. It takes longer than the average. The gait speed is very slow. You can see that. Double support. And just now the left side actually, okay, this is the terminal double support. Elevation at the mid swing, you can see exactly the differences, right? The left side now, I elevate in the mid swing more because that is how I simulate that. Lateral step variability, left and right is almost the same. Second option, you can see that the left side is actually very much higher, 17 cm compared to the right one. Right? Foot strike angle, toes off angle also out of normative. Stance, step duration more than normative data. Strike length is very short. Swing, toes out, turn angle, turn duration, turn velocity, speed slower. We can exactly capture how is their performance after our intervention and treatment. Right? Step in turn. It takes them not many steps to turn. APA duration. First step duration. First step range of All right. So here is how we can actually analyze our performance, our patient performance, whether they improve before and after the trainings and the intervention. Exactly, very easily, and they can compare, in fact, with normative data, or they can actually compare changes from where we tested before and after the treatment. All right. So that is about the Gait analysis. Thank you. I'm going to demo how to analyze my balance using mobility lab. All right, same thing. We have the sensor. So here again, this is the sensor, and we actually have just a receiver connects to a computer, and then we can use it already. All right. So now I'm going to put a sensor at my lumbar. In order to analyze my swift balance, I need to put at my lumbar. All right. So what I need to do is to put new test, and then I will choose swift, foot fit together, eye closed at the firm surface. All right. So now what I need to do is put the sensor at my lumbar, and very simple. So I'm going to test my swift velocity now, right? Okay. With my eye closed. All right, I've completed the test. Let's look at the result. So here is how it looks like. What you are seeing here is my center of the mass. They're drawing the swift. So here, the gray area is actually a normative data, population data. And the blue ring is the average of what my data during the test just now. All right, let's see how it can show with just in less than 3 minutes. Okay, so the swift area, we can see that is within the zone, so 6.61. We can check how is the swift. So here is the sagittals, coronal swift area, and all these frequency, right? The jerk I can check as well, the mean velocity, the path length, and I can actually demonstrate using a z-score, right? From z-score here, I can see whether which one is out of the normative data. So from here, mean velocity of coronal side is a little bit more than the normative data. All right. So now we're going to simulate exactly like, let's say, imagine a patient with some balance issue. So let's see, is there any differences? All right, a very quick one. So let's say I will do a little bit of like a patient who are not so stable. All right. So let's say if I have a patient that may be geriatrics, or maybe I have vertigos, or have some balancing issue. Even though it's a small swift, it can detect exactly, because it's a very accurate sensor. It can capture exactly every moment of my movement. So now I'm doing a swift, a big swift, so that it's significant enough to capture the differences. Okay. All right, let's see on the data. So here we can see that it's exactly where we are. So here we can see that the gray zone, you can see, is a very much smaller. It's because that is a normative data, and this patient, let's say imagine I'm a patient just now, my normative data, the blue ring actually in average is really more than just an average. So from here, let's analyze using this score. you can see that actually it's go out of very much of the normative data. All right. So from here, you can see the all different kinds of path lengths, the velocity, the range, exactly how well they perform in just less than minutes, right? So what tells us from here actually is normally we take patient, we will need to do a clinical test. It takes some time, and sometimes it can be very subjective. All right. So with these sensors and very easy to set up, we can exactly know how well they improve after the intervention and the treatment that we have provided to them. All right. I hope this helped, and feel free to let me know if you have any question. Thank you. Try do it. So now to do the setup, we will already put it at my sensor here. I'm going to do the sit to stand test now to show you how it looks like. Okay, this is already configured, and then we're going to run a new test. Example, sit to stand test. Okay, I'm going to do like a normal person. All right, like a normal person. So let's look at how is my data. Right. Okay. So I need to wait for 3 seconds. Only I can start. 1, 2, 3, 4, 5. Okay, so look at my data here. We can see that, so you can see from here the two colors here. One is sit to stand, one is stand to sit. Right here, we have this duration. So the duration is from the sit to stand. It takes me about 1 second to sit to stand, and this is my angle. Lean angle of sit to stand is within the normative data, 38 degrees. And this is stand to sit duration. It takes me less than a second, right? Because I'm a normal person, I can sit very fast, I can control very well. And this is also within the lean angle of the normative data. It shows that I'm normal. So, right. So let's now look at if I'm a patient or I'm a geriatric patient, I do not have enough strength to stand up. And now we're going to simulate an elderly patient, right? Okay, so this. Okay. We need 3 seconds. Stop. 1. 2. 3. 4. So I imagine if I'm an elderly, I need to lean more in order to stand. 5. And I move a bit slower because of my weight globally. All right. So here is how it looks like. Okay, let's look at the sit to stand. It takes more than a normal person, 1.3 seconds. And the lean angle actually out of normative data already. It takes 59 degrees in order for me to stand up. All right. And then this is the sit to stand to sit. It takes more than normative data. It takes 1.1 seconds. And the lean angle is also more than the normative data. So what it can show here is actually we can detect every single improvement of the patient after the intervention, exactly where they are. And we can actually let patient to understand how they can actually improve after the training treatment precisely. All right, I hope this video helps you to better understand how the portable mobility lab can better analyze our performance faster. Thank you.